Okay, the web services slides are very huge, so that is the reason. It is taking time to load. In the last class, we have seen what is HTTP. HTTP is a protocol that was created by Tim Berners-Lee. It was a protocol about TCP/IP protocol. So, hypertext transfer protocol will transfer what? The name itself tells. Hypertext transfer protocol can transfer what? Hypertext. Hypertext. What is an hypertext? What is the difference between a text and a hypertext? Anything which is tagged is a hypertext. For example, I have something. I will say, I will put it in a paragraph. So this is, I am tagging a, for example, think like I want to put a white box QA here. White box here. So I am tagging a, this is the data and I am tagging it with P. P is a tag element. Right? It's a tag. So why do we tag it? These are called markup languages. Markup languages. So HTML, SJML, XML are all called markup language. You are marking a text with tags. So you cannot do any programming. There is no if block. There is no branching statements, no loops, nothing. You can't know variables. No, there is memory. There is memory for complete document, but you do not do any kind of programming. Markup languages means you are marking something with tags. So all the tags make up that language. So there are two markup languages. Actually, SGML was the first markup language he created, but rather then he created HTML. So then after HTML there is XML. So XML and HTML are nothing but so HTML and XML are the markup languages. Markup languages mark something with a tag. So they are marking some text. HTML is marking for styling. HTML is marking text with styles, paragraphs like italics and bolds, and for example they are marking like a table and everything. And XML is marking with business. XML marks a data with business. For example, it says this is zip code. This is, for example, location. This is address 1. This is address 2. This is a note. This is a message. XML is more about what the data is about. HTML is more about the presentation of the data. Okay. So we will go through that. So HTTP can transfer only hypertext. HTTP can transfer only hypertext. Underneath HTTP there is TCP/IP. It is still making everything bytes and it is sending byte packets only. But what is the advantage we are getting with HTTP? We created a new protocol. See, remember, as the technology improves, as we are growing, we get more abstraction. We are getting more encapsulation actually. We don't want to deal everything directly. We are creating because if there is a new product tomorrow, we are getting interfaces above it, but the technology beneath it will never change. The standard technologies will stay same forever. Similarly, the protocols like HTTP, UDP and all these are nothing but laying out on TCP/IP only. But we give a nice interface because HTTP they can deal with hypertext directly because people don't want to deal with bytes and everything. So in HTTP, as I told, on HTTP you are asking a resource. Remember, when you are talking about a web, you should name this as everything as a resource. Resource means any file, any folder, anything present on some other machine. A resource. It can be a file, it can be a picture, it can be a video, it can be anything. It's called a resource. HTTP is used for hypertext transfer. So resources can be accessed using HTTP. Resources can be accessed using HTTP. So what is a resource? Resource is any file. Okay. So how do I access this resource? In HTTP you have to tell that what is the URL of that resource. Means how do you identify a resource? For example, I want to go to this book called web services book. How do you get there? Go to C folder, C, like for example I want to go to the web services book. Where is my web services book? Let's go to this web services book, this book. What is the path for this one? C, users, something and something. So when you do this kind of stuff, what does that mean is like, this is the path. This is the path to that file. Remember, this is the path, but this is a local path on my local machine. Similarly, when I am going to other machine, what will I do? For example, let's say I want to go to whitebox QA site, qa.com, and I want to go to selenium.php file on that thing, selenium.php. Selenium.php is on the root directory of that server. It's on the root directory of that server. Do you see that? I got it, and HTTP gave me it went and asked it, and the resource is taken, but the browser is displaying like that. But what did I finally get here? That is nothing but this is the page source. Browser, it got HTML, but browser is displaying it like this. Browser is a visual representation of HTML only. Browsers are visual. They get HTML. It is a program which gets HTML, but it is visually representing the HTML to you. So browsers are nothing but a program which will visually present the HTML to you. So, but what happened? What is the protocol which did it? HTTP. HTTP is the protocol, and I used URL to get to the resource, and I got the resource, and I asked the browser to display it. I didn't ask it; it did it. Okay. So this is the thing. So let's see if this really browser is there, or means if this resource is there or not. Let's see. Let's see. Let's see if this resource is there or not. See, this is that whitebox QA machine, and if you see, there is a selenium.php file should be there somewhere. Selenium.php. Where is that? Selenium.php. Do you see that? Got it? So there is a resource on the server. I asked it to give me, but what I have to provide path. For example, if I want something else like student material, notes, and if I want to get this notes, what will I do? I will go to whiteboxqa.com and then go to student material folder. Inside this notes folder, for example, inside this notes folder, let's see this one. Inside this notes folder, and then I will go to this resource. Remember, web is all about resources. See this resource. Got it? A text file, a image file, a video file, a HTML file, anything is a resource in web. HTTP protocol uses URLs. URL is nothing but a path to the resource on the machine. Okay? And there is some other thing called URI. What is this URI? URL means locator. Locator means the path to that. Identifier. URL means uniform resource identifier. Okay? Let's do one thing. See, when I did whiteboxqa.com, did I give any path to anything? But it automatically is showing me what? Index.php. It is automatically showing which one? Index.php. There is a index.php somewhere here. See this one? It is automatically showing this one. Why? That is the identifier. If no identifier is given, go to index.php. For example, let's do this one. Wikipedia.org, and let's search for okay. If you see here, it is not giving me the path. For example, I want to go to this film. Let's say I want to go for this film. Do you see, do you think this is the path? No, this is not the path. Means there is no wiki folder, and do you think like all the files are named like this without .text, .php? No. The file is not shown to you. The path is not exposed to you. URIs means a unique identifier is used to map it to a resource. Okay, so the resource path is not exposed to you. Only a identifier is exposed to you. Why? Because if I do like this, the problem with URL is if I delete the selenium.php, if I share the URL with you, you have to use the same URL. If the resource is not there, what will you get? Can anyone tell me, if I delete the selenium.php file and if the resource is not there, what will you get? The famous error. Anyone? 404 error, resource not found. Okay, resource not found. For example, I want to say ind.php. That is not there. Resource not found. 404 error. This is called 404 error. These are HTTP error codes. Okay, so the resource is not there, so I cannot find it. See, the problem with sharing resources is tomorrow when you share URLs, tomorrow when you give the URLs to someone else, because you are giving the hard coded path. You don't want to do that, because today I might be using PHP technology. Tomorrow I want to do ASPX technology. Tomorrow I want to use JSP technology. You should not expose the path directly. You should not expose the path directly. I should expose only the identifiers. Actually, Twitter is very famous for this identifier. So if you say Twitter, do you think there is a page for every person on the Twitter site? No, there is no resource. Resources are dynamically made, but identifiers are used to map to the resource. Did I make any sense? Okay. So that is more of REST based, because identifiers are more useful. Identifiers give the more flexibility. And where do you configure these identifiers? On the web server. On the web server, you say that this identifier, this resource, that resource can be a real HTML file, that resource can be a servlet tomorrow, that resource can be a DLL tomorrow. Dynamically HTML is produced. No more HTML is really kept on the server side. It is dynamically created by a Java program. It will be dynamically created by a PHP program. Okay, so resources are dynamically created, but identifiers are used to identify what you are asking for. Okay, and actually there is also some more thing, URN also, URN, uniform resource name or something, I forgot actually, and they don't use anymore, and I don't know why they don't use to. Means it's not a name, using a name identifier is more good. What is it? Identifier means it's unique. You cannot use it for another resource. Name means maybe it can be duplicate or something. It's up to your architecture, but I haven't seen anyone using it. Alright, so let's go more. So that is the reason. Generally, the structure of HTTP URL, you will have the host, means the domain name. The domain name maps to an IP address. You know that goes to DNS server and it will get that. And again, then there is a resource. You will give a resource or an identifier. See, this is a resource, means exact URL to the resource. Sometimes you can supply some flags or attributes to the resource. This is called query string. Okay. So HTTP is stateless protocol. Can anyone make any sense out of it? HTTP is stateless protocol. That is a huge statement. HTTP means it's brainless, simple. It doesn't remember anything. It means like it's, for example, after each request response, it's done. I don't remember you. Okay, let's do one example. What is stateless? Yes, sometimes single point takes half an hour. That is the difference. Sometimes 10 slides take 5 minutes. Okay, let's go to the stateless protocol. Yeah. Some people are putting cookies there. Very good. Very good. I like it. But cookies is not the only way to make it stateful. I will tell you more. Okay. Yes. It's good to have a knowledge about this, not mandatory. Okay. This is my local machine. This is where I am giving wide and think like this is my server. Got it? There are resources like selenium.php, junit.php and stuff. Got it? Remember, browser, on the browser you give a request, HTTP protocol request. You get a response back. This is called request response. The page means the HTTP protocol sends a request and the browser waits for that request. Browser waits for that request. Means it is waiting, please give me something. So a session, this is like the programs are tied. Now web server and this client program are tied for this request and response. This is called, yeah, this is called request response. Let me write this again, request response. Okay. So when you send the request, you get the response. But HTTP says, after I get the response, I will not remember you. Every unique request is unique. Means every request is unique. I will not remember you. Whatever you say, I will not remember you. It's not my duty. If you ask me a request, it's my duty to come up with a response or come up with saying that bad resource, not resource found, or some other errors like server error or something. I have to either come up with the resource or I have to come up with a error. That is my duty. So I will get you a response. That is my duty. It says that. But when you send the next response, for example, think like you are logging into bank site. You went and logged in. First you went to Bank of America site like www Bank of America. Get request. It went in. It came up with the home page HTML. Response came. Then you are giving your username and password to this guy. Then you are giving the username and password. Okay, it goes to the database and finds it, and it will comes up with your home page, and it will say this is your account balance and stuff. On this account now you are going to do transfer, but it doesn't remember you. It doesn't remember you. So how can you do transfer on the same account when it doesn't remember you? HTTP is stateless. HTTP is stateless. It doesn't remember anything. The previous request is passed. It doesn't remember anything about that one. So how does it remember then? How does it remember then? How does it only does transfer from my account? How is it not doing transfer from someone else's account? How is it doing that? This is called session management. This is called session management. Remember this? Yeah. Session management. Okay, session management. Let's see that. Okay, so how is the session management happening? So whenever you are doing, when you asked for first time Bank of America, nothing comes here. Okay, it only gets you the HTML. But when you passed your username and password, and when you logged in, when the login was successful, on the server, it creates a memory for you. For every account, for every login session. For example, how 1,000 people are logged into Bank of America, but on the Bank of America server, there will be 1,000 memory slots created for every unique person. Got it? Got it? So 1,000 memory slots. This is called session memory. That's session memory. And every memory has a unique ID. Unique ID, global unique identifier, GUIDs. They will use global unique identifier. Means it will be unique throughout globally. You can't beat that. Got it? So they will use unique session IDs. So when I have this ID, so when you passed me for the login, when the login is successful, I will create a box for you, memory box, and I will put this unique session ID. I will generate a new ID. I will pass that back to you. So where will I put that when I pass it back to you? I will put it in your cookies. Cookies are what? Don't tell me something eatable. They are nothing but a small text files browser uses for every site. Okay. So they will send this cookie. That cookie has what? That ID. It doesn't have your username and password. It doesn't have your. So it will. So when you gave me. So this is the login request. So when the login is successful, it comes back with the HTML. Plus a small cookie to you. This cookie can be placed in your cookies, browser cookies folder, but you might have disabled cookies. You can disable cookies. Then what will happen? It will be in the URL. If you disable cookies, it will be on the URL. Otherwise, it will be on cookies. Now, next time when I am doing the transfer, I am not only sending the transfer request, I am sending back the cookie again, because you gave me cookie, I have to pass you cookie, or it's in the URL. So this guy uses this cookie and finds your box, memory box, and sees in the memory, oh, this cookie, this is the ID, so this is the login credentials, this is the account number, so I have to do a transfer on that account. Got it? So this is session management. But not only memory. This session box, the information session box can be stored in databases, in memory, or in external servers also. So most frequent method is called memory session management. Session and memory. This box will only stay live 20 minutes. If you don't send me any request back, it will expire. That is the reason it will tell that your session is expired, because this box, memory box, will be gone on that server after 20 minutes. If there is no request back. Got it? This is called session management. So session management can be done in URL or cookies, but you need memory on the other side. Okay? So now you understand, even though HTTP is brainless, session management make it really remember everything. Got it? Session management makes it, this logic makes it to remember everything. But HTTP by default doesn't remember anything. You are writing some extra architecture to make it remember. Okay? Okay. So in HTTP, what are the operations you can do? There are two famous operations, but there are actually four operations you can do mainly. One is called get, one is called post, one is called put, one is called delete, and there is one more thing, actually options. Please, I have been asking many students, please read about options and get back to me, but all others are very straightforward. Get means please get me a resource. For example, when you do your first request, I will always be get request. Give me the index.php. Okay, it gave you. Okay. And when you go to login, for example, I went to login now. Okay. So I went to, when actually I should log out. Let's turn off this. One second. Let's turn this off. Okay. I don't want this one. Log off. Okay. So if you are logging, here I am giving something to the site, means I am not only asking something, I am sending something inside. Do you see this one? I am sending something inside. What am I sending? My username and password. This is a post operation. I am posting. But again it comes back with HTML. Again it came back with HTML. Then I am clicking. This is, when you click on a link, it's more of a get operation. When you click on a link. When you submit a form, it is more of a post operation. You are posting, you are submitting something, right? You are giving something to the resource. That is called post. Put and delete. Browsers will not support put and delete. Put means you are creating a resource. So generally, sometimes, not every time, put is never used by browsers. You may think like upload a file is put. No, upload a file is not put. Okay. So upload a file, but you can think it's similar to that. Uploading a file may be like a put, but it is not put. They are not using put command. They are using some other server logic for that. And deleting a file, you can never delete a file using browser. But if you use other protocols like FTP or something, you can delete files, you can play around with it. So that's why these two are very less used. These are the most used and the most. So what is the difference between a get? Get is giving, asking. Post is you are submitting. So whenever there is a form tag inside a HTML, whenever there is a form tag inside a HTML, you are submitting that form, because on the form there is something called method is equal to post. Method is equal to post. And what is that? URL is equal to where you are posting, to which resource you are posting. For example, register.php. I am posting onto register.php. So whenever there is a form tag inside a HTML, what does that mean? You are doing a post. Okay. Whenever you are clicking on links and all this, it's more of a get operation. Okay. So how does it look on the behind? Like, okay, it's good to know that what is a get and post. When you are giving a get, it looks like this one. Get. What is the path of that? And protocol version. HTTP has two versions, 1.1, 1.2. I don't know the difference. Please find it. Okay. So please research it. What is the difference between HTTP 1.1 and HTTP 1.2? So when you can use two versions of that, and where you are, which server. See, I know I'm getting this resource, but where is that? So you can write like whiteboxqa.com. When you're doing posting, you have to do again to which resource you are posting, what version of HTTP you are using, and what is the server where the resource is located. And not only that, you will have more. Why? Because you are posting some text. So you need to tell what is the type of the text, like URL encoded or UTC, means you have to tell the encoding type of the text. You have to tell the length of the text and give a space and tell what you are posting. Like username equal to this one, password is equal to this one, you know. You might be posting that. So whenever there is a post, get is only simple 2 lines, but post is about you are posting some content. So you have to describe the content, and you have to have a line separator and then show the content. Who is doing all this? Who is doing all this for you? Your browser. Got it? You will just click and enter, but your browser does this for you. But if you want to write a program and do it by yourself, you are welcome. Okay? Yes. So hypertext transfer is the language protocol used for communication between web browsers and web servers. And the port type, all the machines generally reserve port numbers for different programs and different protocols. For example, like HTTP is nothing but 80, FTP is 21, FTPS is like 22, SFTP is 23, and HTTPS is 483. People will ask you protocols. Please remember it. Knowing HTTP is not knowing get and post. You should know what port numbers is used. What is the difference between two operations? So the port number for TCP, the port number for TCP is 80. Actually, HTTP works on 80 only. So, and HTTPS is 483. I will talk about HTTPS, and FTP is 21. I think I have put a slide for that port numbers too. What are ports? Ports are nothing but the windows. Small windows where a program can look for particular type of request. Means on your machine, see, many people want to communicate with your machine. All cannot come through the single door, right? You open different doors for different people, different protocols. Simple. Ports are nothing but doors. Got it? So that you identify who came, you by knowing the door, you will know who is coming through that. Understood? So URL, URI, URN, uniform resource identifier, uniform resource name, uniform resource located. I already have explained this one. Okay. So URLs are more of a path. URLs are more of a path. So it is nothing but it is exposing the directory structure on the web server for you. It's bad. Personally, you should not do it, but many people still use URLs. Okay. And because URLs are, that is why wherever there is URL, you will mostly get 404 error. Okay. If it is a URL based, 404 errors are common, because if they deleted that resource, if they changed the name of the resource, done. This guy got that URL and he's still trying to access that one. Okay. So that's why uniform resource identifier should be used, but it depends on the company. Okay. So these URLs are also used by FTP also. So host name, port. Sometimes in the HTTP, actually you can give, for example, like local host. See, this is my local machine, and I can say 80 means on port 80 go to like index.jsp. I do not know if it is there. Okay. So see, you can also give port number too. You can also give port number. Okay. All right. Agreed. So you can use port numbers and stuff too. In URLs, you can also ask a different port also. So you can run applications at different ports. So you can, by default it is 80, but you can change it. You can put it in the URL. So the methods: get, retrieves a URL, means you are asking a resource. Okay. Posting, you are submitting something to the resource. Agree? Geeta is asking me, is each URI connected to a URL? No, never. It might be connected to not to a HTML file. It might be connected to a servlet program. It might be connected to a DLL. HTML is dynamic, right? So doesn't mean that it might be connected to a URL. It might not be connected. So the question again is each URI connected to a URL? No, but it is connected to a resource. It is connected to a resource, but not the same resource this guy wanted, where the logic is written, where something runs there. Means I am telling a resource. Yes, it knows the resource. The server knows its resource, right? It means a local path. Means a URI is not connected to a URL, but URI is connected to a local path. URI is connected to a local path. There is a path, of course, there will be a path, but it doesn't have to be URL. Because they are on the same machine. It already went to that machine. It can use C colon something there. It doesn't have to use again HTTP and again all this stuff. Am I making any sense here? So one more question I got here is, so URIs can also give 404 error. Yes, maybe, may not be. If a URI is not tied to any resource on the server, it will give 404 error. But most of the time there will be a error resource also. If nothing happens, do this one. So that is the logic of URIs. Yes, all right. Okay, everyone got it. So I don't have to, okay. Yes, and one more thing, get and post, you know that, see, put is used to transfer a file from a client to server, but browsers won't support it. There is a head request. Head request means this is a crazy request. Like for example, when you ask for a get request, you are asking it. Means it is the resource will come to you. But head request means before asking, you are doing a trial check. Like for example, oh, are you really there? So give me just the header information. Oh, if you are there, then I will ask you. Means it's like pinging and checking, and then you will give your request. Got it? That is called head request in HTTP. To make sure that is, if the head request fails, you don't need to give the real request. So it's a trial and error case kind of thing. Okay. All right. HTTP packet request sent from client and all this, you can read all this. Okay. All right. So please read this. Okay. It means the what is the header information used in the HTTP, means generally like from whom, accept which language, and for example, is there any authorization needed, pragma, any tags more needed. So this is some of the header information. You do not need this div, but if anyone is interested in HTTP, please, if anyone is really want to see the depth of HTTP, go through this attributes on header elements. Okay, referrer, authorization, charge to. Okay, sometimes it is used for making them more secure and stuff. Status header, response header. Okay, coming back to one of the famous thing, HTTP codes. HTTP codes. 200 means successful. Means you gave a get request, it came up with OK, means I gave you HTML, the resource is there and I gave you. For example, you gave a put request and it says, oh, 201 created. 200 means successful messages. Okay, 300 means information messages. 300 means information. Okay, for example, it's a for example, it says, oh, I moved it. It just gives for information purpose. 400 means something failed with the resource, problem with the resource, your request. The URL is bad, the resource is not there, you don't have permission to that, it's unauthorized, you know, it's very secure. So all these are 400 errors. 500 means your request is right, but something went really bad on the server, like there is a power off, there is a program didn't run very well, crashed, or something bad gateway or something. 500 server. 200 okay messages means good messages. I do not know how to categorize, you find it. Okay, 300 information messages, 400 request error request messages, 500 server error messages. Got it? So I already told statelessness of HTTP, and we know how to make the HTTP stateful. Stateful means it remembers its own past state. Okay, you can also use hidden types also in HTML. There are hidden types, but especially when you use ASP, PHP, JSP, they will use session management, like what I have told before. Session management. Okay. Okay, what is SSL? For example, I gave this one. This request goes on, it never comes back. Can I do anything with that? No, I can't do anything. It goes on, it will be means it will be, my browser is tied, means it will, you know that it is tied, until it comes back it can't do anything, right? But it goes on for hours, days, years. If you want to wait, you can wait, I don't care. Means the response doesn't come back. First thing in HTTP, there is a response doesn't come back. Response does not come back. Okay. One more thing is, I am putting, for example, into this site, for example, in whiteboxqa.com, you are putting your credit card information. It went. But when I am sending it to whiteboxqa, when I am sending, see, I am putting it on this site, my credit card information here. There should be a guarantee that it will go to whiteboxqa.com only. Security should be provided. Means it goes to right server or right destination. Okay. And one more thing, there should be guarantee that no one can steal it in between. Okay, it is going in between, someone took it. No one should not steal it in between. No one should not steal only, no one should tamper it, means change the message. No one should not should not tamper the message. And then there is okay, no one should steal the message. Even though they steal the message, even though they got the message, they should not understand anything. Even though they get the message, they should not get my credit card information. They should not get my message. Means, how is this? Encryption. Very good. Encryption. This is, there one is called integrity, one is called something. There are cool definitions for it. You can find about it. If you search in Wikipedia SSL, it will tell. HTTP will not give any guarantee of all this. SSL will give the guarantee. So HTTP plus SSL is nothing but HTTPS. HTTPS is slow. Don't use HTTPS for even small request. See, automatically pages are HTTP from the beginning, but automatically when you go to the payment page, it became HTTPS. When you go to the credit card payment page, it becomes HTTP. So all requests should not be HTTPS. Only secure information should be travel using SSL. Got it? So SSL guarantees all this. If it goes to the right person, no one can steal it in between. No one can tamper the message, and no one can make use of that message. Encryption. There are mistakes in typing of the H. Yes. I don't know. It's okay. Board should tell me. PowerPoint is not telling me. I will not change it. Okay. All right. Okay. Yeah, it should tell me. Otherwise, I will give the slides. You correct it. All right. That's all for HTTP. Let's take a break and come back for web services. Okay. Let's see what is the fourth line. See this one. Distributed applications. What are distributed applications? Remember, I told you before, TCP IP came and everything changed actually. Before even internet came only, softwares changed a lot. For example, before, let's go to new diagram. So for example, there is one machine. If you install a program, it will work on this one. But think like there is another machine. There is another program. If you want to, this program wants to talk to that program. If you can make this communication possible, that is very good. For example, Yahoo Messenger works like this. Many applications, chatting and video conferencing. Not only that, machines needs to talk to machines. Application on one machine needs to talk to other application. So what is the base protocol for this one? It is nothing but TCP/IP. Got it? TCP/IP. So people used TCP/IP, but as I told you, TCP/IP is very low level, means it's on the byte level. So when people are using TCP/IP, got it? So how did they use this to make applications where one application communicated with another application? So, for example, remember this application can be made by Java. This application can be made by .NET. Agreed? So in the olden days, people worked on protocols. And technologies. Okay. For example, C++ worked on something called Corba. Corba means a C++ application can talk to another C++ application, another C++ application running on same machine, different machine, it doesn't matter, anywhere, as long as I can connect to that machine. Another C++ application on any machine using Corba. You might have heard this in 1995 and 6 and 7. It's very famous technology, Corba. Okay. So Corba is a technology. Corba is nothing but it's a C++ technology. Where two C++ applications can talk. After Java came, then Java said that RMI, remote method invocation. Got it? Remote method invocation. Okay. All right. Invocation. Then .NET came. It said DCOM. Distributed Component Object Model. Okay. So why are we talking about this? Means you might be thinking, like you said, you will be talking about web services. Why are you talking about all this? Distributed component model. Okay. Model. Okay. Let's see component object model. I know there will be spelling mistakes. Okay. So if you are keen and if you are into the class, you will find the spelling mistakes. Okay, what is the full form of Corba? I don't know, I forgot. Corba, what is the full form of Corba? I don't know. Something component object or C object or something. I forgot that. You can do Wikipedia right away. Okay. So what does this mean is, remember, two machines talking means two applications talking. Two programs talking. A application is made in a language. A application is in, I know I can send TCP from here to here. But who is sending it? Who is receiving it? There is no human sitting inside a machine, right? So there is a program which can send TCP, your bytes using TCP, and there is a program on another end which can receive TCP messages and which can give back the response, right? So using the TCP means, so there is a programming language. So we are talking about programming languages because a program, a application is made by a language. So there are technologies made based on languages, not open. Means there is no common technology. There are technologies made in the olden days. The technologies made based on the language. So for C++ applications, it's called Corba. For RMI application, for Java, it is called Java RMI or RPC. Okay. Java RMI remote method invocation, and for also .NET it is called DCOM. All of these are called as RPC calls. In programming languages, developer calls it as RPC calls. RPC call means, remember, see, if there is a, for example, there is a tax method here, there is a salary method here. Tax method will use the salary method. Means a method is, see, they are on the same machine. They are in the same memory. It's not about even machine only. It's called same process. What is a process? For example, every process is a boundary. Remember this. I know I am going too deep. Process is a boundary in a machine. Boundary in a machine. Where it has its own memory allocated. OS allocates memory and processing type, CPU for it. Every process is different. For example, one process is trying to open a file. You are going to delete that file. It will say, no, it is used by another process. They see that permissions, memory, process, CPU is all by process. Process is a boundary for a program. This program's boundary is that. This program's boundary is that. So they cannot go out of boundary. A program running, every program runs in its own process. So it can talk to any method inside its own process. A program can, for example, a small procedure or method or subroutine, I don't care, whatever you call it, or even function can ping or can call another one in same process, same memory running process. See, program is running. When a method calls another method, means what it is, that it is calling another method in the same process. So remote procedure call means, RPC means remote procedure call, means it is outside the process. Remote procedure call. So a program is calling another program method. So that can be on the same machine, different machine, it can be in a different country, it can be anywhere, it doesn't matter. So these are called RPC calls. For example, a function inside a method, inside a program is calling another function which is not inside its process. That is called RPC call. So it can be anywhere, another procedure can be anywhere. Okay. Got it? So this is called RPC calls, remote procedure calls. So when you are using remote procedure calls, so this why it is called distributed application. Why it is called distributed? Because the programs are distributed over many machines, but the solution is single application. The solution is coming from many machines, many processes, many programs. So that's why it is called distributed applications.
means the programs are distributed over many machines. That can be same building, same country, same city, it doesn't matter. Distributed applications, distributed applications, got it? So these are called distributed. Every technology had its own technology, like a Corba for C++, Java, RMI, .NET, DCOM, and now they use something called WCF. Yeah, I do not know if Veena is here. She's a .NET girl actually. WCF, Windows Communication Framework. Communication Framework. Okay. These are all proprietary. These are all proprietary, means that Microsoft owns WCF, Microsoft owns this DCOM, Java World owns RMI, actually Sun created RMI. So now, for example, Corba, C++, everyone owns it. Okay. Now, why do we need distributed applications? Why do we need distributed applications? First of all, you might be asking, for example, simply, you won't be using Skype today if you have not seen RPC, right? Skype won't be possible without RPC. Okay. Alright, and someone found the full definition of Corba, Common Object Request Broker Architecture. Very good. Okay. So now, what happened is, like, with these technologies, it's like, for example, Google, if you go to Google page, like, let's say, for example, see, some other, let's say, for example, Yahoo. Let's go to yahoo.com. Okay. And if you see yahoo.com, you will see, for example, go to weather. Let's say weather. Where is the weather? Okay. If you see, do you think Yahoo has a satellite and something, and it is, you know, that it is getting the weather from weather.com, right? How? So Yahoo program is calling weather.com program, and it is getting the weather, but it is using its own user interface to do this. See, weather.com displays it differently and everything, but it is getting this weather from weather.com. So Yahoo program needs to communicate to whose program? Weather.com's program. Both programs are talking to each other, applications are talking to each other to give you the solution, distributed applications. Agree? So when you are doing this one, see carefully. Is there any guarantee that weather.com used Java and Yahoo used Java only? One can be .NET, one can be Java. You never think like this, right? When weather.com started, it chose its own language. When Yahoo started, it chose its own language. So with these architectures, like using proprietary models, what happened is, like, you cannot communicate with all the applications. There is no common standard in the industry. Industry felt like, okay, I know that .NET uses DCOM, but mine is a Java application, but I still want to talk to .NET. How can I do that? Do I have to create one more .NET application for that? No, I don't need to. So we need a common platform. That's what world was looking for. Okay. That is where web came into picture. Okay. So what are the considerations? So when you use distributed applications, what are the considerations? Generally what happens is, like, data types are not compatible. In Java you have a string. You should have the same kind of string in, for example, if Java needs to talk to .NET, same kind of string should be there inside the .NET also. So server failures or loss of server response. Of course, if server is not there, you won't get the request back. Response back. Client failures. So when there is the request and response, it can fail on the client. 400, it can be fail on the client. It can fail on the server too. Okay. Retrying a call. And one more thing, actually, when there is a distributed applications, you should be remembering one thing for sure. Okay. For example, what happens is, like, you submit a order. Think like Amazon. On Amazon, you are submitting orders daily. Okay, you are submitting orders on Amazon daily. Do you think, like, it is directly going into its database or something? May not be. There will be a service layer where it takes all the orders, because you have a 24 window to cancel it, or 2-day window to cancel it. It goes to a temporary place. After everything, it will go to this one. Okay. So generally, when client and server are, client and server are communicating, the failure can be on the client side. The failure can be on the server side. See, whenever there is two applications talking, one is called client, one is called a server. Why? Because one application needs something, other application gives something. One is a giver, one is a taker, right? Always. Most of the time. Okay. I know there are chats and other things, but still, okay. Yeah. So one is a giver and one is a taker. So when you're doing client and server kind of stuff, so the failure can be on the client side or failure can be the server side. You submitted a order, but you think that failed. You will resubmit it. Do you think you are creating a duplicate, or do you think you are starting a new one? You will never know. So request and response should be very clear. Resubmitting a request doesn't mean that you are solving problems. Architecture should be laid out to which will define each and everything about request and response. So making distributed applications is not a piece of cake. You should think that, okay, if a request failed, should the user submit the request again? If you submit the request again, are we submitting a duplicate record again? 2 orders coming up. So many people fail at this kind of architectures. Okay, architecting this kind of things is not easy. Okay. So retrieving a call, security, and one more thing. For example, you are submitting an order. You are in East Coast. You are submitting an order. Got it? But the database is in the West Coast. See, distributed application. The server application is on the West Coast. You submitted an order even before the time didn't come away. Means you submitted at 11 o'clock. Is it 11 o'clock yet? Here? No. But we are storing the order here. We are storing the order here. Time frames. You should manage time frames. When a solution comes from many applications, that application might be in India. One application might be in West Coast. One application might be in East Coast. But all are talking. Time synchronization should be there. For example, if a person is submitted the order like at 11 o'clock from East, and it went into a database on San Francisco. Now he goes to a page. I want to see all my there is a page. He wants to see all his orders, but this order is not showing up because it's not time yet. Programmers should know this. Designers should know this. Time constraints, time zones, how to store data, which application manages which thing. So it's not an easy thing coming up with the distributed applications. Synchronizing clocks, security. Okay, security is also one primary thing about distributed applications. Thank you. All right, considerations. So these are all called RPC based architectures. What is an RPC? RPC, remote procedure calls. These are calls made to procedures or functions that reside on a remote system. Synchronous. They are all synchronous. Believe this. There are two kinds of calls. Synchronous, asynchronous. Synchronous means I made a phone call to you. If you don't pick it up, what will happen? I can't talk to you. Right? Asynchronous. I left a message to you. You can check back sometime later. You can check back sometime later and you can get back to me. Simply, let's look at this one. Okay, simply, let's look at this one. This message, this application wants to talk to this application, but this server is not available, or this program is running. Two programs should be running. Remember, two programs not compiled should be running on two machines, and they are running on a port. Right? So when the two machines are running on here, if one machine is not responding, one program is not up, the communication won't take place. So when it is looking for this one, if this is not there, it will come up with a bad response saying that not found, or it's not responding or something. So these are called synchronous. That's why people created asynchronous architecture too. This is where how two different kind of applications can talk to. Did anyone hear about MQs, messaging queues? IBM MQ, MS MQ, Microsoft MQ, that is the thing, asynchronous. So here is a program, here is a program. These two programs want to communicate, but they will not communicate directly. You will put a MQ here. MQ means it's a server where you log your messages. It's not for logging, it's queuing. Logging is different, queuing is different. Queuing means so that it can be dequeued too. So this guy says that, please give me, for example, this guy wants tax from here. This is a program. This is a Citigroup application. If you give the SSN, it will give you the credit score. This is a credit card application system. Everyone will use this one, right? So this guy will give the SSN and say that, please give me SSN credit score for this SSN. He will put it in a message packet. This is a common format. It is not proprietary to Java, .NET or anything. This guy will keep on looking at this one. If this is there, he will take it and he will do whatever it is and he will put the response back. This way, guy will be looking at the response. It's like your voicemail, text messages. So people used MQ structures. These are called MQ, messaging queue. Messaging queues. Messaging queue structure so that they could do asynchronous communication between application. Okay, between applications. Okay, got it? Alright. So this is one way, but the problem with it is MQs. The problem with it is like you have to order the queues. For example, one message may be dependent on another message. First you ask the assistant something, you ask something. There should be ordering maintained. And asynchronous means it's not live. Asynchronous means it's not synchronous. First of all, means you have to wait. You do not know when will you get the response. You are not tied up. So that is one disadvantages too. Okay, so there are so many other kinds of disadvantages. So but the problems with RPC, let's see one by one. So message based architecture. Okay, so but this one thing, you have to convert it into a message format, then take message format to again Java format. So interoperability, this is called interoperability, means no you can't, means there is so much of overhead and you can't do that. That's why people saw this. Even though HTTP and HTML were created to show web pages, to show the research pages, why can't we use two machines can use HTTP, right? So people thought like, why don't we use HTTP, right? Two machines, anyone can understand HTTP. HTTP is not owned by Microsoft, Sun Microsystems or anyone. It is open standard. So why don't we use HTTP? But do you want to send HTML using HTTP? No. Why would I send bold, italicized? I want to send a message. I want to send a message like get me SSN, means get me the credit score for SSN. Do I have to include bold, italics and everything into that? Heck no. Right? Simple. Because it's all about presentation. I don't want presentation. So what do I need? I need some other thing where my tags are based on business XML. So people thought like we should not use. People are still using it. They will still use forever. RMIs and everything. But if you want an open kind of communication, you can use RMIs and everything for your own local communication on your own, for example, internal companies. For example, if a company is following Java standard, they will use Java standard only for within the company. But they don't have to use Java for outside the company. Right? Because when it is outside the company, interoperability is the key. Means you should be compatible with every kind of system, every kind of platform. Right? But using the Java protocols, it's very fast. Web protocols are very slow. Means comparatively, but not very bad. No, they are not bad actually. So, but Java protocols are very fast because they are working. They know how to do it. They are dealing with their own way. So that is the reason. Programs, even though applications are written in Java, even though applications are written in C#, even though applications are written in C++, doesn't matter. They can still send a HTTP request. But in HTTP, what can you send? You can either send HTML or XML. So please use these two things. So when you use XML and use it to programs, see, we used HTML for a machine to human interface. A machine to human interface. This is coming to a human interface. So that's why you need presentation, because people want to read it. You need to be visually appealing. But when you're doing to programming program, you don't need presentation. You all need is what is the data and where is that, means what is the data mean and data. You need what does the data mean and data. So that is why people choose the XML. In 1996, he created XML. Actually, Tim Berners-Lee thought that he should have created XML first, because XML means anything. XML means anything which is tagged. So HTML is also XML. That's why XML is HTML. A version of HTML is called XHTML. When you write a HTML document as a XML, then that is called XHTML. And W3C recommends XHTML, doesn't recommend HTML at all. Okay. Problems with the web. The only problem with the web is security, but people have solved that kind of problems. They gave more protocols on security and performance, and they have so web services are also very good. Means not only web services, this kind of communication. So there are many kinds of web services. There are 3 kinds of web services: RPC based web services, SOAP based web services, REST based web services. How many types of services are there? RPC, SOAP, REST. So now we have to start learning. We have to start from XML. So what is XML and where do we get there? I'm recording this. Please focus on this. All the current world is about current data, transactions. This is called transactional world. Transactional world means you go somewhere, you buy something that goes into their database. Why? Because the transaction is made, because you might come with the receipt and say I want to return it. You never know, right? So transactional world, current data, this is all why we use it, because we to maintain the day-to-day transaction. For example, appointments, schedule, everything. BART timing. See, if you go to the BART station, it will tell the next train will arrive in next 5 minutes. How will it know? Because there is a schedule of trains made in the database of BART system. It will use the current time to give match up and which train is where, and it will tell you it will be in 5 minutes. Right? So it's all about transactional world. Transactional world gives you knowledge about current data. Okay, business is running fine. A business is current data is all about using RDBMS. Current databases use RDBMS. Yes, I don't want to say RDBMS, ORDBMS. Please don't ask me what is that. Go to SQL recordings. Yeah. It will use ORDBMS because it has procedures, functions, triggers and everything. It will use objects and it will use tables and everything to do that. Transactional current data is working. But tomorrow, for example, a company like a Walmart, company like, for example, I need to see what happened in the last year. For example, there is a Walmart here. Walmart became popular. Actually, there is a story. Kmart didn't do data warehousing. That's why it went down. Walmart did data warehousing. That's why it went up. I will tell you how it happened. Yeah. So think like Walmart, it's going fine. Yeah. Walmart wants to see last year's data. Means even though it's not current data, there is a data piled up. When you're doing transactions, you get data piled up years. But you don't want to use it in the current data. Why? Because think like we passed 1 year. We can dump the whatever the data which was year or more years old. We can take it and put it on another server. Why? Because if there is huge data, the performance of this database goes down. We only want to deal with current data, because think like BART schedules. Does it need old year schedules in the current database now? It can put it in another database. It won't throw it away. Why won't it throw it away? Why? Let's see. They'll put it in other databases. So why would they put it in other databases? Think like Walmart wants to know what is the top selling item in last December. Got it? Okay, it will go and look at the last 1 year database and it will see in the records from last December, and it will do a query and it will find out that this one. So why did it do it? It can prepare for this year, because during Christmas time, what is selling more? It can prepare so that it can do the inventory for that. It can do this one. It can do like, okay, which store made huge sales? So it can focus more on there. It can give more people to there. So why do we do this one? This is called data analysis. This is called business intelligence. Okay. This whatever transactional world is called OLTP, online transactional processing. Transactions. You are processing transactions. This is called OLAP, means analytical processing. You are doing analysis. You are not doing any transactions on it. You are doing analysis. This can be called warehousing. This can be called mining. Mining means you are doing an algorithm deeper into the data to get something out of it. Data warehousing is only about making a structure of queue and finding, like, for example, I want to know when I made last year's data, I want to do something like, for example, give me the top selling item per month, by store, by, you can do this, can buys. These are called dimensions. Because it's a multi-dimensional data. This is called multi-dimensional data. So you do this one. Data warehousing is making this multi-dimensional data and querying it. Mining means writing algorithms and queries on it, going deeper, writing algorithms to get something. You are trying to find out, for example, least performing store. You cannot say least performing store from just 1 year. You have to do so much of data mining there. You have to do, because why did it affect? What are the factors? You have to find the factors. You have to remove them. You have to do a probability there. So this kind of many things go into data mining. Okay, that is OLAP, OLTP. That's it.